In section 6.5, you're going to use factoring to solve polynomial equations and also identify multiplicities of roots. Now, a root of an equation is any value of the variable that makes the equation true. In section 5.3, you found the zeros of quadratic polynomials, and we called them zeros when they were written as functions. So f of x equals ax squared plus bx plus c. Now, if the quadratic polynomial was written in the form of ax squared plus bx plus c equals 0 instead of f of x equals, instead of saying zeros, we said roots. Now, in section 6.5, you will be finding the roots, which means you're going to set polynomial equal to 0, and you're going to be finding the roots of polynomials of degree 2 and higher. So to identify how many roots of a polynomial equation has, you want to look at its degree. So, for instance, if a polynomial has a degree of 3, that means it has 3 roots. Now let's talk about multiplicities. That's a big word, but really all that it means is the number of times a root of a polynomial appears as a factor of the polynomial. When a real root has even multiplicity, the graph touches the x-axis but does not cross it. So let's look over here at the diagram, or the graph here. Here the graph is touching the x-axis, but it's not crossing it, so it's just turning right there, kind of like it's bouncing off the x-axis. That means it has an even multiplicity. When a real root has odd multiplicity and greater than 1, because if it has a multiplicity of 1, that means it's going to go right through the x-axis because it would be linear, unless we have a horizontal line. So when a real root has an odd multiplicity and it's greater than 1, the graph bends as it crosses the x-axis. So here's an example of an odd multiplicity that is greater than 1. It's going to bend. All right, now I'm going to be using the terms factors and roots quite a bit, so I want to make sure that you understand the difference between what a factor is and what a root is. If we have 3 as a root, that means x minus 3 is the factor. So this is what you get before you set it equal to 0 and solve for the root. Here is a factor. If we want to find the roots, we set it equal to 0, and here x would equal 4 for the root. If we have a factor of x plus 5, we would set that equal to 0, and our root would be negative 5. Now, if we start with the root of negative 2, that means that x equals negative 2, so we would bring this over to the other side. We would add 2 to both sides, so we would end up with a factor of x plus 2. All right, now we're going to use factoring to solve polynomial equations. And here are the steps that you need to do. You want to set the polynomial equal to 0. Always pull out the GCF. Now we need to determine the factoring technique based on the number of terms and the degree. So you did quite a bit of work with factoring in section 6.4. Now if I look at this polynomial here, it has a degree of 6 and it has 3 terms. So first thing we want to do is to set that equal to 0, and then we can pull out a GCF. Now the GCF is going to be 4 because I can pull out a 4 from all 3 of those terms, and the highest degree I can pull out for x is x to the 4th. So when I pull that out, I have x squared plus x minus 6. Now we can't factor that any further, and so we look at this trinomial of degree 2. Now I can use the factoring technique a times c. We need that to add up to b. So we want factors of negative 6 that add up to 1. And the only combination factors of negative 6 I can have would be 1 and 6 and 2 and 3. If I make this 2 negative and the 3 positive, when I add those two together, negative 2 plus 3, that will give me the 1x that I need. Now since this coefficient is 1, I can jump to the factor term right away. So here are my factors. I have 4x to the 4th, and then x minus 2, and x plus 3. Okay, now the next thing that we're going to do is set each factor equal to 0. So when I do that, here I'm going to end up with, if I divide by 4 and then take the 4th root, I get x equals 0. Here I have x equals 2, and here I have x equals negative 3. Okay, now our degree was, or is, 6, so that means I have to have 6 roots. Okay, when I look here, I only see 3, but what I want to remember is this has a degree of 4, so that means this root is going to happen 4 times. So it's actually going to, when we would write it out, we would have 4 of them at 0. Okay, so when I write the roots, I have negative 3, 0, and 2, but that doesn't identify all 6 of my roots. So what I have to do is use multiplicities. And you just say how many times they appear. So I'm just going to use the word m because I don't have a real large blank there. So negative 3 has a multiplicity of 1 because it only happens 1 time. 0 has a multiplicity of 4 because of this degree here. And then 2 has a multiplicity of 1 because you only see it 1 time. So now when I add 4, 1, and 1, I end up with 6. So I do have the 6 roots that I need. Now down below, I'm just going to quickly factor this polynomial, and it's going to factor into x plus 2, x plus 2, x plus 2, and I'm just going to do that quickly so I can show you the multiplicities. Again, we set each factor equal to 0, and we have a root of negative 2, but this says I should have 3 of them. So what happens, that root appears 3 times as a factor. So we would say we have a root of negative 2 and it has a multiplicity of 3. This is a difference of perfect squares, so that factors quickly into x minus 3. X plus 3 is equal to 0. So if we have something equal to 0, the first factor has to equal 0, second factor has to equal 0, or they're both equal to 0. So we're going to set them both equal to 0. So x minus 3 equals 0, x plus 3 equals 0, and when we solve, we have roots 3 and negative 3. This says I should have 2 solutions, or roots, and I do. I have a 3 and a negative 3. So each one of those have a multiplicity. This m is just for multiplicity of 1. Okay, now when you flip it over to the other side, these are just some reminders. When you are factoring a polynomial equation, always remember to take out the GCF, which is the greatest common factor. Look at the number of terms and the degree to decide which factoring method to use. And then refer to section 6.4 for factoring techniques. When you're solving a polynomial equation, set each factor equal to 0. And when identifying multiplicities, you determine how many times the identical root appears as a factor. Okay, you have a couple of you try it questions. I want you to solve them and also identify the multiplicity of each root.